So today is 20th. Time is 4 o'clock. We have to do activity 3.3 in your textbook. Is that correct? Because I think we hear about these intermediate values, and so we have to do this. This I have given in the website also as an assignment. You can log into this site. Have you logged on to this site? I have given you the username and the password. Here under chapter 3, logic gates and logic circuits, here is the assignment. When you open it, it will be like this. Draw the logic circuits and complete the truth table. So that is what is appearing here. But I thought you may not be able to do it. So at least one or two I will do here. So the first one is x equals 1. So this is a statement. You are familiar with these statements now. I will copy it to the document. In the Excel worksheet, it's difficult to do. There is the A section. X equals, actually equals 1 if A equals 1. This is or E equals 1 or A equals 1 x 0 and this is B. E equals 1. So this is the statement. What do we have to do? We have to draw the circuits and complete the truth tables. We have to, two things we have to do. One is draw the logic circuit. The other one is the truth tables. Is my speech clear?
Yeah.
Because I saw a message, internet connection is not stable.
Yeah.
If my speech fails, you can knock off your mic, mute yourself, and also video also. Then it will be better.
I think.
Yes? Yeah. Yeah, better take off.
Yeah.
And it will be okay. So then we have this thing. The two things we have to do is to draw the truth table and draw the logic gate circuits and the truth tables. So let's try this one. X equals 1. If these conditions are true. So what are the conditions? Now we have within brackets two conditions. See? A equals 1 or P equals 1. Actually two conditions we have grouped in one group, and the other group is there are two conditions here or also A equals 0 and B equals 1. So between these two there is an OR gate. Is a gate, an OR gate. So let's see, we have to put it at the end. Right? First, A equals 1 or B equals 0. So we have to have another OR gate in front. Here, let's see. Here we need an OR gate. Don't worry about these other shapes and all that, the shadings with a lot of difficulty. So let it be. But you understand, this is OR gate. So A, if A is here, B is there. A or B. The outcome here will be A or B. Then here again there is another one, A and B. So you need an AND gate here. A and B. A equals 0 and B. Here we put A again. A, B. So this we need another AND gate here for the second condition. A equals 0.
Uh,
One moment. Right. So you need an
yes, sir.
AND gate for this and A and B again. So the outcome of this will be, what will that be? A dot B. Right? So these are the two. Then, so these two we have drawn. Then this gate, the last one. So we have to send both through this. Hmm. And then again come down. So here, then the final outcome is this. But we write in a Boolean algebra way is A. Do you by any chance see my screen flickering or moving or something? It's happening in my screen. I don't.
No, sir.
No, no. You are seeing this. I think my computer, the memory is running out. So it's just flickering and all that. But doesn't matter. I can manage. A dot A plus B. Oh, really difficult. What happened here? A plus B bracket, then it's another plus, and then within brackets A dot B. Okay. So then what about the second section? The second part of the question is, now first one, draw the logic circuits and complete the truth table. We did the logic circuits, and the second part is draw the truth table, complete the truth tables. See, for the truth table, we have to get a 1, 2, 3. There are so cursing the wrong place. How many columns? Not columns. We are not sure of the columns. Rows. We need how many? How many inputs? It's not 4. It's 2. A and B.
4 inputs.
No, it's 2. It's 2. Like you can say that.
Yes, yes.
Can you understand?
4 rows.
Yeah. If you don't understand,
4 rows.
I can do like this also. See, A is coming from there. Another one, B is coming here. Right? Something like that. See, though for convenience we draw like this, but only 2 inputs, only A and B. Same wire from here will be connected to this. Same wire B will be connected to that. You understand? So it will be 2 inputs and 4 rows. Very good.
4 rows. 2
One.
inputs and 4.
So I am taking 5 because we need for the heading also. So let's take a few extra here. A, B, then some intermediate things, and here outcome is, let's say X. Here we have extra here. So writing the whole thing. So A as usual, 0, 0, 1, 1. B, 0, 1, 0, 1. Here we can calculate. We'll calculate this one, A plus B. So we'll have it as A plus B. So can someone tell me the answers for that column?
First is 0. And
0.
And
Yes.
0,
0.
0, 1.
0, 1, 1, 1.
Yeah, rest of it is 1.
1. Yeah.
Tremolo always from the other side, no?
No, sir.
Right. Okay. So this is wrong, no?
No, sir, I said 0, 1, 1, 1.
Yeah, that is the correct thing.
1, 1, 1.
That's correct. This is wrong.
Yeah, so that's what I
This is
said.
wrong. Yeah. But you always say from the other side, so I don't know which one you're saying. For 100, you say 001. Remember? So anyway, never mind. So this is wrong because 0 or 1. So one of one is 1, no? Is also 1. That's the way. You gave for A plus B. So let's see that. A and B. A dot B. For that, A and B, then that's correct. So it will be 0, 0, 0, and 1.
Only the last one will be 1.
That's right. But both have to be on or 1. So then Next one is what? Next one is straight away this. X is this. This or this. This or that. This or that. So again, or 0 here. What is it? Now you have to take this
1. All
column
3 are 1.
and the other column.
Yeah.
These two columns. So this is 1 because it's all
1.
All 3 are
1.
1.
So this is the answer for this. You don't need this column. Delete columns. Then to select all these and go like that. All right. Then do I need to do the rest or can you all manage? Advanced and complicated, but I think you better manage it on your own. So you can upload it here. Here you can do this and upload. So I can check it, right? No need to email anything. Here itself you can upload and it will be recorded. So remember, it's going to be serious. All your work will be recorded. Then we'll go to, so today we'll start 3.5.3. Activity 3.3 as well as 3.5.3. So that we'll be doing today. And now that we are here, we'll mark the attendance. Tremolo is yes. Actually, no. Clara, yes. Dishika. Inandi, at the moment, yes. Mohammed, no. Wahan, no. Afif, no. Very poor attendance. I'm going to report. Tell your friends. To the school, I want to tell. Because I thought I can handle this. All will come. But it looks like some force has to be used, which I don't like. So then we go to 3.5.3, example 3. A wind turbine has a safety system which uses 3 inputs to a logic circuit. A certain combination of conditions results in an output X from the logic circuit being equal to 1. When the value of X is 1, then the wind turbine is shut down. The following table shows which parameters are being monitored and form the 3 inputs to the logic circuit. So there is a turbine speed, bearing temperature, wind velocity. So do you know the windmill? Wind turbine, you know the wind turbine system? There's a windmill, it's turning and then it's connected to this turbine which will generate electricity. Generally, you can get any other mechanical things done, but the most important utility is you can generate electricity. It works like a motor then. Motor in the reverse. So turbine speed parameter, the name is S. We can use labels like S for turbine speed, S for speed. Then if it is less, if it is low, like less than or equal to 1000 RPM. What is RPM? Revolutions per minute. Revolutions per minute. So the turbine, the turning 1000 revolutions per minute. If it is less than that, 900 or 800 or 700 something, then it's 0. But if it is more than 1000, it's 1, the values. Then the temperature, bearing temperature. Bearing is part of that machine, like balls or something to keep it going smoothly. So, but it thereby it is increasing the temperature of that. So it is dangerous if it goes very high. It's very dangerous. You have to shut down and wait till it cools down. So the temperature, if it is low temperature, is 0. If it is high temperature, is 1. Of course, the range is given there. Wind velocity, if it is low speed, 0. If it is high speed, more than 120 kilometers per hour, it's 1. So we have all the details. Now let's see what are the conditions. These can be, out of these we have to build the conditions. These are the values. The output X will have a value of 1 if any of the following combination of conditions occur. So output, if the output is 1, if X is 1, the wind turbine will shut down. It is given here. Either, so there are 3 conditions. Either turbine speed is less than 1000 RPM and bearing temperature greater than 80 degrees, or turbine speed greater than 1000 RPM and wind velocity more than 120 kph. Or there's another one, bearing temperature less than 80 and wind velocity more than 120. So there also there's a danger, because if it is great, very high wind velocity also, there is a problem. So how do we design this? How do we get about this? Either, so if this is true, I mean these two, there is one condition here, turbine speed less than 1000 means speed less than 1000 is 0. So if S is 0 and bearing temperature greater than 80 is, T is 1. So if S is 0 and T is 1, it is enough to shut down. There is an AND condition. So because of that, and the gate here, so because of that, both have to be true. Just because turbine speed is less than 1000, it won't shut down. It has to have the condition, this one also. So that is one. Then forget about that. There is another condition which can turn off the wind turbine. That is these two conditions. Then there is a third one here. So can you do it? Can you do it? That's the question. We can start like this. By writing the Boolean algebra notation for this. But let's take the x equals 1 if turbine speed, let's take this one here, is S, and what is the value? 0, no? Less than 1000. You can write if S equals 0, sorry, if X equals 0, and bearing temperature greater than 80, which means if the temperature greater than 80 is 1, and T equals 1. Follow carefully. Okay, so you write this. Then we take the other one, or. There's another one coming in here. So you can put or there. Turbine speed T is 1, no? Sorry, speed is S. S is 1 because it's more than 1000. How do you write that? Speed S equals 1. Here again and is coming here. And second is velocity. With velocity more than 120, which means W is 1. There's another one. So connect it with or. Temperature less than 80 is T is 0. No? T equals 0 and wind velocity greater than 120 is 1. W is the notation. Now we'll convert it into the Boolean algebra. How? S equals 0 means not S. Like 1 is on and 0 is off. 1 is true, 0 is false. Understand? Say for example, we learned that when A goes through a NOT gate, A becomes not A, no? Not A. That means if A is 1, it becomes 0. Not A. So here you can write not S, isn't it? This way. Not S or even this some use like that. We will do S dash or S bar. I can't put a line, it should be there, or even this is okay. S bar, S dash, and this what? Dot. Dot. T, sorry, this should be equal. S dash and T, just T. T equals 1, 1 means, T equals 1 means it's T. If T equals 0 only, it's not T. So here S dash dot T, then that all remains like that. Second one is S equals 1 means S. Unlike here, earlier it was S equals 0, and then here is S equals 1. So it's S. For this and, you put a dot here, and W equals 1 means W. Yet another or for the third condition, equals 0 means T dash, and this dot, W equals 1 is W. So this is the Boolean algebra statement where we can draw the logic circuit. We will do that in the next part. So now take a 5 minutes break.